Amazing. Post it, we're live. Cool. Seems to be going. Right. So, last stream, we basically run some stuff. We're trying to work on this sort of brick shader. So, we've just got a cube mesh, and we are shading it with 3D texture coordinates. So each vertex of the cube has a 3D position inside. Currently, it's just the local space position of the object, but it could be whatever we want. And then we've got this brick material, and we're trying to basically make a proper brick material. So you see here, this sort of border is meant to be the sort of concrete. We just need to make it a bit thicker and bring it downwards. And yeah, then it should be good, basically. But yeah. And what we're seeing is a normal map, because we're just trying to visualize making sure the normal map looks correct whilst we get all of the surface information of the SDF looking fine. So effectively, when we draw the cube in the pixel shader, we're just ray marching into the material. That's all we're doing. Nice and simple, and the performance seems to not be too bad. So, you know, compared to the parallax occlusion map, and it works for the sphere as well, which is cool. We're just doing everything in 3D. So it will mean we have to use expensive 3D noise functions and stuff like that, but yeah, it'll be fun. Right, let's start with a quick prayer and then we'll get going. Right, dear Lord, thank you for this day. We bless your holy name. Thank you, Lord, for providing us everything we have. Thank you for the peace in our land, the food on our table, the money in our wallets, the cars on our drives, our children, our wives, our family, and the fact that there's still a chance for many people to be saved. You know, help us, Lord, to do your will on this earth while the time remains. And yeah, help sanctify us, purify us, and any evil that's lurking in our hearts still, Lord, reveal it, shine your light, and destroy it in the mighty name of Jesus. Yeah, help my viewers today have a good time watching, learn some things, and help me have a successful time. Clearing through lots of things I want to clear through today in today's stream. And yeah, just pray for just pray help us in our lives, Lord. And I pray that each and every one of my viewers will come to know the truth and the love which is Jesus Christ. Thank you, Lord. In Jesus' name we pray. Amen. Right, there we go, guys. So, right. We started doing the border last time. And like, so it's like distance brick, this guy, right? So it's just returning you know, you give it a sample position, it just returns you the distance to the nearest edge. And if you're inside, it's negative. If you're positive, you're outside, yeah? And then you just keep stepping and stepping along a ray line. Now, the unsigned distance is for the border, because I was thinking I probably can't generate a distance. Or yeah. I was thinking let's just make it unsigned distance to make it easier, but I think what we could just do is another box, basically. I think it's possible. Yeah, so the reason why I did an unsigned distance is because what I would like is I would just like to put a wall down, basically, and still be able to peer through it, kind of, in ways. without having to start stepping the ray. I think here's, let me see if I can draw it to explain it a bit. So the problem is we want to try and put down some sort of cement wall. Right, here's our ray, our camera eye, and all the bricks here. So we want to kind of visibly put a cement wall down. When you're looking at it from the outside, you'd always hit the cement wall, but it could actually be quite thin, maybe. And then this allows us, no matter where it starts, if the mesh is actually smaller than this, say, and there's another brick layer here, the cement wall will just be here, right? That. So that's the sort of plan. That's the reason why it looks a bit thin. It's a bit offset. It's a bit wrong. So, so right, let's keep the window up. Oh, all right, here we go. So we want to try and make this border kind of in the middle. So I guess we can move it around, right? So it's kind of along the right. It's on the wrong Y for some reason. I don't know why that is. Right, so I reckon we could do a box. Another box. Say. Then if we did more boxes, that would... Yeah. Hmm. Yeah, so we kind of want to put... We also not want it sort of hanging off the edge maybe as well. Yeah. I guess we go back to the drawings. So what would be nice is if the cement somehow... So you want it to go through sort of the middle of all the bricks. But it'd be nice if it didn't do this, right? Going off out to the next one, right? But then, so you'd just have this sort of bit hanging here. But you see, it's kind of possible if we made... Yeah, so I think what we could do, I wanted to try and avoid this, but having lots of specialized materials for every single brick wall, I think we might have to just do it. So what we could do is just clamp it all off at the edges. And I think that gets rid of lots of problems. Like you see it's peering through to the next ones at the edges here. So what we could do is if we just go back to the scene shade. Times 2. Make -1, 2, 1. So, wait, it makes it -1 to 1. I'll make it 0 to 1. Potentially. Um. In that case, we just offset it by 0.5. Because it's just the way they are. They're -5 to +5. 0.5. Right, I wonder what happens there. Okay, so that's... So my UV... Let's get rid of the... Oh, come on, what's the problem here? Oh, the hot code reader didn't work there, that was a shame. Right, so now we've got it -1 to 1. Sorry, 0 to 1. We can do a thing. We save the final, after the ray march here, we can say if any of shading UV is less than 0, is there an OR function? How do you process the you have to use AI to get anything sensible from Google these days? You can do that on Boolean. All right, any or right. I guess all or any, isn't it? What am I looking for? Right, so and on for a Boolean vector in it. Bvec 3. But I want to preserve it for the... Hmm. Okay, I guess it's got to collapse it down. If any less than... It's probably better if you just collapse it down then. or if any greater than. Right. Do, 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 do. Oh, okay. You got to manually make it the vector of the right type. Yeah, because it doesn't do that. Always forget that. Cool. So yeah, it's clamped out now, as you can see. Oh, excuse me. So as you see now, it's not staring off into the infinite, uh, infinite brick world, if you will. Although it's sampling the sky though, rather than trying to render anything else, which kind of sucks. That's a bit problematic. Anyway, we'll solve those problems as we go. But yeah, so if we take that out, you see, you go off into infinite brick world. But now it doesn't. Yeah. So we use stuff like this, which is cool. Now, so this means yeah, so it seems like the brick starts from like the lower left and it's bottom here maybe, and it's half showing. I think that's the original point. No, it's not really, is it? Maybe it's this one here. No, no, no. Yeah, I don't know which edge. Oh, that one. Yeah, it's starting from there maybe. So yeah, that's the origin position lower left. So we could go back to -1 to 1 though. Hmm. Yeah, I think let's just make it -1 to 1 since it's 3D. And we'll do it that way instead. So it's times by 2. From our current local space. It's a complete hack, so won't bother trying to understand that. Right, so here we go, back to here. So that discard, less than -1 now. Right, so change that around. Cool. Right, so that's looking nicer now. They all fit in there. Um, Now, if we do this sort of border, put the border in. Yeah, why don't that want to work anymore? But you didn't recompile, did it? Man, is this like an if Friday piece of code? Why is it why is it not working today? The hot code reload temporarily. Right, that's a bit funky. Yeah, we're trying to add this border in now. So I'm thinking, right, we would like to, yeah, just put some kind of like wall down, if you will, between all of these. But then probably on the last one, we don't want anything, because if not, we'll just keep going through, right? That's what we want to try and avoid. So it's as if like, so you could do like a pattern thing where you're basically saying, right, draw me based on this brick, draw me, there's going to be this sort of line, if you will, that's always drawn. And this sort of line, which is always drawn. But then on the edges, it will basically like only draw that, right? And that's just repeated across every single one of them. That's something we could do. And you just get a distance to that sort of, you know, that plane, if you will. That's one way of doing it. We could also just have a bunch of planes that just get put down, right? At every, that's probably the best way to do it. Just get a bunch of planes repeated. I think there's an SDF for a plane, maybe. Let's check. Yeah, it's just a dot product in it. We could just lay down a bunch of planes repeated, like alongside the oh, excuse me, alongside the bricks, and then we just have to find a way to sort of short circuit it around the edges. So I guess let's try this guy. So position local space, the normal. Normal must be normalized. Well, it kind of makes sense. Yeah. So what is H again in that? Isn't it some sort of like offset? I think we can find that in. I think in a plane though isn't really a proper SDF. I think. Oh, I wonder what that sound was for a minute. That was confusing me. It was what sound? Right, so they've used the SDF plane. So yeah, so we change this. This is like a height from the ground. Yeah, it changes the sort of the offset, if you will, along the normal vector. Yeah. So I guess so. Right. So you can call that like. Let me call it the height. It's kind of the offset along the normal. Okay. Right. So basically, we shouldn't need an offset, I don't think. So let's go to. So you do this gridify at the box, and we should be able to use the gridified UV. The normal, I think we'll do a few of these actually. So the normal would be vec, one for each dimension. But we'll just start with one dimension for now. We'll get that working, and then we can do the rest, yeah? And then 0 for the offset. So I think we can just do that. What? That's fun. Not really much of a plane, is it? Looks cool though. You know, just add a sine. You know, just add a sine wave of time. Maybe not. No. Anyway, bit weird how it's got Oh, I did box. That's why. Of course. Plane. There we go. So you got your slices. That's what we're looking for. Now, so it's actually perfect. Now, I think if we change it, because we've got a different camera angle, let's make it so we can actually... Or, actually, it's probably no perfect camera angle. But yeah, as you're seeing, it's filling... Oh, no, it's not perfect. Close, though. So I think we want to offset it by, like... The offset would probably be, like, half the dims along the vector type thing. Maybe a 4? Hmm. We want it to be like... Oh, that's a multi... Oh, yeah, multiplier is fine. Yeah. So... That's kind of cool. Yeah, it's cutting off because it reaches 1, I think. So it cuts off because it... Yeah. So this border wall probably stops spinning the camera so much. Let's go to game. Bye. Bye. Fixed theta. Cool, it's looking quite reasonable. We just need to switch the dimensions, so I think I'm gonna go down the Z now. Nice, so here we can see what's going on. So, effectively, like, if we move... We want it such that this border is, like, in between... Yes, it seems like you can't have it. So what kind of cycle we have to do them both ways? Because that's not what we're looking for. Why does it? So when you're remarching it from this way, okay, it's doing a dot product on the plane, and then therefore it gets it's the wrong way around, right? Yes, it's that dot that. Right, so it's underneath, right? So um right. So you probably ABS. And that probably gets what you want. Hey there, JD Husk. I'm just trying to work add a border now to this brick using sign distance fields. That's the plan. So we're just trying to. Oh, interesting. Yeah, so just trying to add a border to this, so like a cement layer, if you will, and then basically cut it out around the edges of the material, effectively. So it's got this sort of coloring because it's just the normal, right? The normal map. But yeah, it's a 3D material, so it's just a cube, and we've rendered the surface using triangles, and then we're ray marching into it using sign distance field functions, and this is the sign distance field here, and then we're going to shade it in properly later on. So it's a completely configurable procedural brick. No, it's in Vulkan, but it's basically the same thing, right? Vulkan DirectX X12. Um, yeah, so we have a bunch of different properties that we pass in from CPU side, basically. So it's runtime configurable if you want to do that. Right, so this is sort of what you want, right? If we had that going across all the dimensions, that would be great, I think. Yeah, it would be. So, yeah, this is good. Like, so now all we got to do is find a way. Like, if I was to show you quick. So, oh, hang on. Min D2, and then a min D3. Yeah, so you've basically cut. Can you see now we've got like a border that's showing up. All we need to do is get rid of the extra. Excuse me. Oh, a little bit ill. Oh. All we've got to do is get rid of this sort of like the sort of extra bits on the end, if you will. Just it's as if it's like packaging. You have to sort of like bring down that excess bit of it's not packaging. Stuff has been printed out. You know what I mean, and tear off the excess edges that we used to make it stable during the um, the creation phase. So, cool stuff, man. Been learning Vulkan from their docs. Yeah, well, Vulkan docs are not that great. But yeah, there's like you can use the you don't have to use like render passes anymore and frame buffers. You can just use the dynamic rendering extension. Um, synchronization, they make it so impossible to learn, but it's actually very simple what it is, and what it abstracts over in hardware is very simple as well. But yeah, man, it's the worst. But yeah, if you've not done it already, use dynamic rendering in Vulkan. Use Vulkan 1.3 plus, 1. Or 1.4, and use this extension slash feature. Yeah, throw these guys in the bin. Exactly. Literally took the words right out of my mouth. Get rid of all this stood vector, right? Don't do that. But yeah, none of it. Yeah, just this stuff. So the way I was thinking about getting rid of this excess stuff here is, probably. Man, it would be great to have like a min 2, min 3 function, but anyway, a min 4, but there we go. Now, oh, that's good. Like how I was thinking about getting rid of it basically is like, the dimensions of the bricks, the UV goes between -1 and 1. So we can just assume that when you're on the last brick, right, just sort of cut everything else off. It's a thing we can do, right? So we could. Oh. Great. So you know about that extension. That's good. But there's docs. It's right with C++ in my opinion. So really, why have you been learning C++? Oh, they write in with C++, right? Yeah. And also you've got that guy's name. What's his name? It's like Sasha, but it's not Sasha. Sasha, whatever his name. Sash. Yeah, Sasha. Sasha Williams, or maybe it's Williams. Yeah. Anyway, this guy, he's got his documentation and he for Vulkan, his samples. But again, he does the more of the C++ side. I don't think he uses Vulkan HPP though. That thing is an absolute mess. Vulkan HPP, man. Can you believe they made that thing? Obviously, it was code generated, but man. Yeah, this guy's got some samples as well, which is useful just to see things, but yeah, Vulkan, when you understand it, actually, you realize it could be taught far better. They worry about getting in all these specification the specification language of like, oh, when you do like the barrier code and all that, just reading the documentation for that is like, it's like an alien language, but it's very simple how to do it. Yeah, I'm a little bit ill. I'm fine. I can think and everything like that. It's just I'm sneezing a lot. But it comes in waves. Sometimes it'll just be fine, and then it just come like for like a few times. But yeah, it's just the way it is. Bum, 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 bum. Yeah, so what can we do with these distances? So for these specific ones, we could probably clamp the GUV. Ooh. Thank you so much. Appreciate it. So the problem is it's been repeated, right? And so what we should probably do is make more of a clamped gov. C cgov. And I reckon what we can do with a cgov is it will be a clamped version of UV, right? Where it's like, so you got the brick dims, right? You know where that last brick is going to be. It's like, so you know how many bricks you can evenly fit, basically, right? And you want to get that center position of the last brick and the center position of the, the first and last brick, and basically clamp your thing in between that, right? So you want to have the first, last brick pos UV. So that'd be like a um yeah, I was thinking like these brick dims, maybe the brick dims is what no. Hmm. Well, what we could do is have a parameter where it's like, how many bricks do you want? Rather than the size of every brick. So yeah, I'm wondering if we had like a brick wall that was laying down. Do you want to specifically say, oh yeah, the brick is like this size in UV space? Or do you want to define it as, here's how many bricks I want in this space? Right? I think that's probably a better thing. And then the border will probably be a percentage of like how much of that brick space do you want there to be a border? And I think that, yeah, I think that's what you want. Yes, I think if we shuffle it around for that, then it means that right, let's just put something in for a sec. And we'll right. Cool. So let's re-architect the input data. So I reckon what we actually want is like how many bricks. So there'll just be a vector 2, and you go, maybe you can support up to 200 bricks. I don't know. Well, what do we do? Brick count X. Yeah, maybe 256 ought to be good enough. I don't know. We'll find out. And then the border dim is like, hey, how much of this? It's like a border ratio. How much of the brick are we gonna take up with border? And we've got colors, we've got glossiness as well, because you might want glossy bricks, you never know. And we'll have some offsets too. All right, I think that's what we want. Now let's go to. So rather than brick dims, that'll be brick counts. And hang on. So what we would like, you know, maybe. Well, let's just keep it even, right? 4, 4, 4. And then let's just say the dim, like the percentage, if you will. Let's just take up 10%, right? Then we'll go back to the shader code. Let's bring these in. Counts. Be an IVEC, UVEC. Cool. Border dims. How big? Yes, I think we might still have a brick dims, maybe. Let's make one just in case. So that'll basically be a length of 2 in UV space, divided by how many bricks do you fit in there? Yep. And that can come back. So everything should still work as normal. We can transition over to. Hang on. Oh, it wants to upgrade. That's not very nice. Dev amend. I need to run it a second time, I think. Ba-dum, ba-dum. Hang on. Gotcha. I see 5 bricks. I see 5 by 5. That is not 4 by 4, right? Yeah, I need to recompile that. Oh. It does this sometimes. I don't know why it does that. Yeah, we need to regen the UI doc. I think. Oh, I gotta fix some bugs in the code base. But I can't be bothered at the same time. Because I'd rather do other stuff and live with the bugs. Bam, 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 bam. But then one day I'll be swimming in bugs and I have to go bug hunting. Right, border dim should exist, right? Did someone delete the border dim? Oh, it's border ratio. What a better name that is. So we're going to a ratio of the brick dims. Whoa, mind blown. Oh. Hey. Excuse me. Right, so instead of too large. Why, why is it doing this? This is like an if Friday piece of code, you know. It's working fine before. Yeah, so we looked at this in the past. Well, I looked at it off stream in the past, but I couldn't find anything to do with it. And I forgot what I did now. You know what? I got ideas. I got ideas. Build directory. Yeah. Let's delete it. Rebuild everything. No. We did try deleting those as well, though. Bum, 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 bum. Man, nothing has like changed, but yeah. Right, let's hop in the encoder thing and fix this up. So, something to do with type fields. There's like a global that's not set properly. Shouldn't be too bad to find, I think. We should be able to search for that. Yeah, T fields. Right. But in this case here where it's being used, so we punch in a, oh, there's an index. This one then, FJ. Right, so this, right, so it's probably, yeah, it's got a very large number. So this FJ, what it's trying to do is calculate the field structure of, so it's doing like a takeaway, right? Getting an index of that pointer basically from structure fields this. But that format structure field that we set it to just before is actually coming from something. Yeah, so this is not being upgraded basically from the old encoder database file, I think it is. So where's the upgrade? There's a translate. Looks pretty alright. So if we have a new, so we're going from so effectively with this encoder file, So it's just basically C-like syntax, but it can do like bit fields and range types and default values. And then we have this database type, which is basically is exactly the same except for everything is super explicit, and it also supports versioning. So I think what's happening is it reads the database in first, and then it reads in the the file for it, the current file for it, tries to merge this file on top of the database, and then one of the yeah, the pointers is just dangling to the old one, kind of thing. I think. So right, gen type. It's the VLA struct type, or it could be the struct type pointing the wrong one. Right, if you have a struct type, translate the structure type all field. Right. So it's just a complete copy. So we get the field index from the VLA strut type. Fields. Interesting. We get the offset already. Can I look at that? Yeah, VLA strut type. Yeah, the translate code looks alright. So it's going to the VLA structure type. Is it a VLA though? It must be. Bum, bada, bum, bum, bum. Yeah, it's this one here. Or the tabs one. This is how UI is saved out into one of these files. Bada, bum, bum, bada. Right, and build. And J, wouldn't it? Yeah, struct then fields, yeah. So I would like to know what this number is. It would be nice to see that. Yeah, so it does a translate on the structure type, stores it in, and then we do the field by reconstructing it from the new type. Yes, that's fine. Maybe it should do a find based on the identifier, maybe. Might be better. It works for now. Yeah, so what other things could be a problem? So we've got it's the generation code. No, it's the parsing code, isn't it? So this code is only triggered if there's a VLA structure type. This should all be pointing to the same stuff. Right, so when we okay. So when we do a translate of a structure, its fields, what are we doing? Right, so it just tries to find and then it gives you back. Okay. I don't understand when does the structure type get overwritten then? Does it get overwritten in other ways? Right, I was gonna print out some stuff now. That's bizarre. There's no reach here. It must reach here, right? So that would be a so rebuilds the exe. It's not rerunning the code gen though. Oh, so a dependency of you would be this guy. Yeah, it would be nice to make that dependency as well. Anyway, yeah, so I see it's not regenerating. So what we have to do is go to doc, change that file. Yeah, so 0, 0, 0, 0. So it's there. They're all as zeros. So that's interesting. I think what we can do is, since there's not many, we can just output a few things, right? We'd like to just output basically like, hey, this is the pointer for the type, and then probably we'll call it new type. Then we also want to output a pointer for the and then if not, we'll just hop in the debugger if we, yeah, I think we'll get so far with this. All right, so we also, when we get to that place where it's going to do the generation, yeah, we would like to just do that, yeah, so call this F, go to UI doc, right, have a look at that. Right, so when they get translated, these are sort of looking similar type handles. Then 60, A5, 9A. Right, it's interesting, we've got a 9A. Like, yeah, so some of them don't get translated. So, which ones of these? Okay, so some of them don't get translated. Some of them will be. Yeah. So, Look at fields, strut fields, something like that. So all right, now there's one more place where this gets made, I think. Yeah, right, when it parses it. Okay, cool. So try that. Yeah, right, let's run that. That's cool. Here we go. So bunch of numbers. So basically on these Fs, we want to know the ones which are not equal. So this is the structure fields array start index. Like, because in that file, the only times we use VLAs is when they're basically the first or the second one, I think. Yeah. So, yes, when they're, and of which it would be a point of difference. Well, yeah, maybe we should have just done a takeaway. Yeah, so let's go back to the Fs. It's not these, is it? Sorry, ZD in it. Yeah, yeah, yeah. So it'd just be a this take that. So UI doc. All right. Cool. Yeah, so got some negatives here. So these candidates. So this is the type pointer, the pointer to the data type. So where's that made? Well, it's done here, right? No, 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 it's not. It's not. D6D 0. This one. So what's different? So I've got the type. I'm remember them now. So right, the type, the structure type, this the fields pointer, and the field that we're trying to look at. So this D. So this one's the. Oh no, I got confused now. Oh, come on. 9A. Yeah, it's this one at the top. Yeah. Cool. So this one's the same. That's good. But then this is different, right? So this is the fields array. It's different. But then the field pointer stayed the same, I think. Yeah. So the fields array change. So I think I know where that code is. So I think what we ended up doing. There's a thing that I did to do the upgrade, I think it was, when you take. Where is it? This is when it's just parsing. It's not there. This is some primitive types. Not there either. About to parsing again. So, okay, that's a bit weird. Why would the fields array change? The full... Yes, this translate code. When you bring in the... Yeah, when you merge the type table in from the current encoder file into the database. So it just brings them over. So you go over every type. If it's a structure... So if it's text, which this one is not text, is it? It's binary. Is that right? Oh no, this one's text. Yeah, so it's text. So the fields, yeah, we just go over all the fields and merge the types over. Right. Yeah, this is it. Right there. Encodifier may have added fields. Use the source arrays, as inserting them will be too problematic. Right. So that's how the pointer changes to the fields. Okay. So I found where the bug is. How do we solve it though? So the problem is we're holding a pointer to a structure field and we want to take a difference. Maybe what we could store as well as the offset, but as we've seen here, there could be a different number of fields in the structure. So we want to just go over, just use that pointer now to the fields or the array to the fields, and then go over and translate each of them over to the new type table. So right. And when we translate the array, here it's going to say if this translate right. So I think what does it translate it? Where's the 9a? No. Oh no, so it'd be a would be is this structure seen multiple times? It is the 5. Yeah, the strut type 540. So yeah, 540 different field pointers. Yeah. So yes, the problem is we're in the VLA, we're storing a pointer to the field instead of an index. But the issue is you could store the index and then it'll be pointing to the wrong field when you do this translation stuff, probably. Yeah, I thought it was all in declaration order anyway. So you should come across the structure first, and then when you come across the array, it should just rebuild it all. Right, because you've got... You're just doing this here. Right, but you got a 9A0. Your 9A0 would be... On a 0. So, right, there it is. Yeah. So the this VLA is going to get updated first. Then we come and translate this. Yes, then we come and translate this structure later, and its field pointed to the array of fields would then just be overwritten with the other one. Right. Okay, how do we solve that problem then? So that happened since we added in 4 declarations, basically, this bug came in. Okay. So what we could do is just do it by name and then we just look it up. That's what was probably best to do. Like we do it anyway here, right? So VLA ident hash, yeah. So this is the way it always will be. Then if you want the struct field, you basically just say, locate, you have a find. Yeah, type find field. We've already got one, yeah. Pass in the string. We should probably want to have it with a... Right, it's not forward declared. And voila. Cool. Amazing. So we got this guy. Now, here's what we're going to do. We'll get rid of this and we'll call it build ident hash. Bit long. There we go. Now, so VLA ident hash. Now, that can be an issue. So that'll be a strut field, is that what you call it? Oh, man. ident hash equals 0. Nice. All right, we're in a good place. So, unfortunately, what we have to do is be able to get the VLA strut field. So VLA field. So type find field with hash. So it would just be SF type array dot structure type. Look for me in there. Right, so you just got to do it in here as well. So nice. Nice. All right, so I think we're in a good place there now. Let's just have a quick little look around. Right, here's another one. So we just want to copy over the hash. And then we should be in a good place and everything should just work. Hang on. Oh, lovely. Lovely. Right, so I think we're in a good place there. We now just have to recompile. Sorry. Change that file. Now we shouldn't be hit into that bug anymore. There we go. Right, we're past that. What a terrible detour. Ah. Right, anyways. Glad that problem is fixed. Right, so we're back to this. We're trying to make borders and stuff. So we're trying to make bricks. What we're seeing is this sort of cement layer. It kind of looks like it's offset now in the wrong way. So let's go back to the shader, graphics materials. Yeah, so here's what we did. We tried to sort of say, right, we want to define our bricks based on like numbers, like how many bricks want to fit inside this area basically for the material, rather than, so we do 5 by 5 by 5, rather than defining a specific size of a brick in UV space. We're just saying how many fit in here, and that all gets calculated. Then the other thing is as well is the border ratio would be like how much of the brick is going to be have a border on it, that sort of thing. Now we're completely messed up so if we just get it to return instead D0, which is the bricks. Here are the bricks. So what we're seeing is it's not really evenly fitting the bricks nice to the border. So clearly something is wrong. Yeah, I think what we did is, yeah, so now what brick dim means is the total size of a brick is the spacing from one brick center to another brick center, but the border is included in that as well. Let's say that. So what we're looking for is we're calculating this, the spacing of the brick. Yeah, so this gridify. So take it in the UV. The spacing is actually just going to be this now. So we said 5 by 5, didn't we? Well, that's 3 by 3. Something is off. That's 5 by 5. Why? Right, something's off by 2 here. Why has it got to do this? I shouldn't have to worry about that. But yeah, so this is the spacing. Right, I guess it is 1 divided by... Oh yeah, of course, is it? No, because it is a... Where's my UV? Yeah. Oh, so... Your brick dim... Oh yeah, there's a time 0.5. Something like that, I think. Oh, what's going on? Yeah, I think this is fine. Because we're not accounting the border in on this, are we? Yes, this needs to be take Z border dims. Something like that. Right. Hang on. Hang on. So times 0.9. So it should be 5 by 5. Yeah. So that should be what we need then. So the problem is the size of this is too big for some reason. Yeah. So we did times 2. Okay. Um, yeah, so I think this needs to be the spacing. Oh, this is meant to be a half dims, that's why. Oh, okay, we got it now, we got it. Yes. Right, that maths checks out. I wonder why. Right, so the spacing from one brick to the next brick is brick dims. Yep. To make it half, you obviously need to half it. Then, because that's what box takes in, it takes in a half dimensions. Now we need to offset, just take the border, not 2 times border, just 1 times border. This is a ratio, right? So the ratio, so let's change this out for a minute. If we gradually increase this, so 0.0, right, be nothing, no border. 0.1 be 10%, 20%, 30%, 40%, 50%. Right, clearly the maths is wrong because that's 100%. So that would then, oh yeah. So, yeah, it needs to be, yeah, this needs to be halved as well. Lovely. Lovely. Right, so I think that's, this is probably what you would want in some ways, but since we're testing it, we would like a bit more of okay, so we can put the cement back in after this. So we've got the new parameters in there now. These are much better to work with. So the reason why we switched over to using brick counts rather than brick dims is because we wanted to because we wanted to know where the last bricks were such that we could basically get rid of the border. So let's just change the attributes passed from CPU side for a minute. Let's up that to about 3. Right, so we're going to now place our border down. Again. So we change the sign distance fill function. Bum bum ba-dum bum. Ba-da-bum ba-dum bum. Right, our borders are back. Now they're a little bit off, but it's fine. It's fine. So yeah, the reason why they're off is because we've decided to change how the gridify function works. There's no longer plus something else. That's a lie. Yeah, it was no longer plus. Like our brick dim now means like how do you step from one brick to the next brick rather than being the actual size of the brick. Yeah. Maybe that's the wrong way of saying it. Yeah, maybe we can rename the variables in a minute. Let's just get it working and then we can do the rename. So the thing we want to do is basically cut off on these final bricks, these planes, right? So we've got 3 planes being drawn and repeated because we've just got this sort of repeat thing. Now I've added the second repeat thing, this gridify as it's called. Now we're going to clamp the UV such that nothing such that the border doesn't exist from the center position of every single, like after the center position of every single edge brick, if you will. And that should get rid of it across every dimension. And then we shouldn't see the insides of it anymore, which would be cool. So, so that would then be just a quick bit of maths. You basically know the number of bricks, the brick count, right? So if you take the brick count, half it, yeah, brick count, half it, and then times it by the size of the brick dims, and that gets you that center coordinate, I think. So it's like, to get that past in. All right. So basically, you just do a vec3 z brick dims. Do you think it's difficult to land a job as a graphics programmer nowadays? It's never really been easy, to be honest. It's always a bit of a faff and a struggle. I think what you got to realize is when people say it's hard to get a graphics job and tell everyone on the internet about it, it means quite a lot of people are now not going to try anymore, right? So it's kind of like a self-balancing mechanism, right? So if you try when loads of people are not trying, you're more likely to get it, right? Now, um, yeah, I only landed mine when I prayed when I prayed about it because I kept trying for so long, and honestly, I was not landing it. Every time I put the CV out, nothing, no bite. So I keep working on my side projects, come up with, some new portfolio every time. So I prayed and fast, and yeah, then I had 3 bites. Splash damage, and there was someone in London doing embedded software development. But then I got in the interviews, and then he sprung a thing on me, and I was like, "Hey, it's Python." So that was from the devil, and that one was charging. They wanted to give me 30 grand for the year salary, and I have to go into London every day, and going to London every day costs £10,000 a year. So you take home money is less than 20k to live on. So I was like, no. So yeah, just build a portfolio, right? Do the best you can with your own effort, and I recommend you pray about it because you should be able to land a job if you, yeah, just keep looking, right, and keep trying to hone in on your CV in your projects, right? Keep trying to do the next thing which bears more visible stuff, right? And try and the thing is, companies want you to kind of specialize as well. They don't care that you're good at everything. They don't care you like everything. What they care about is, can you do this job? Um, quite a lot of the time. What do you mean future proof? Were you talking about because AI and all that? I wouldn't be worried about AI. Like, because put it this way, if AI is going to take every job, it takes every job, and that's a big problem to solve for the whole world, right? Then we're all screwed. But I don't think AI is going to really be. So either it's going to be like, I reckon, right, with AI, it's got 2 ways. Either what it's actually going to do is just enable us to do more quicker, and we're going to go through a phase of a lot of uh, a lot of AI slop. That's the phrase, isn't it? We'll go through lots of AI slop, but eventually people will just get fed up and people will know AI slop, don't like it. Right? The market will correct. And then companies, we're going to go through a bit of fire. companies will like, you know, they're gonna like be like, oh, I can get rid of all my staff, and people do all that, right? But then new companies will come along and just own those companies, and those companies that do all that stuff will probably burn up in fire. And people with real talent will rise to the top, basically, because the AI slop will be noticeable. Or it goes the other way, and it actually does replace every job, and then you've basically got the problem of everyone's job is replaced. So how'd you solve that problem? And then people come along, communism, and then socialism, and try and shoehorn that in, because there's probably a way to do it without communism and socialism, but the more you look at it, that just seems like the less thought one you could do. But yeah. But my bet is Jesus coming back. We all know what the AI is going to do. Read the Bible. Revelation 13. Let's get a proper translation. There is robots and AI in the Bible. It's been there in plain sight. The false prophet, beast of the earth, is going to tell the men. Well, he's going to perform signs in heaven, bring fire down from heaven, right? He's going to deceive all those who dwell on the earth by signs which he granted to you by the sight of the Antichrist, telling those who dwell on the earth to make an image to the Antichrist, who was wounded by the sword and lived. So he gets killed like Jesus, right, and resurrected like Jesus, and people marvel at him and say, who can make war with this guy? And he takes over the whole world. And he has an image of the beast, which is a robot, and is granted to the false prophet to give breath to the image, such that the image of the beast should both speak, AI, right, and all who do not worship the image, killed. Walking, talking robot, which kills everyone. So that probably comes. And what you need is Jesus to escape all this. So, yeah, this is going to be a real bad time. Yeah, get praying, get right with Jesus before all this stuff happens. The Bible's predicted all this from the beginning. Just go wait and see how long it takes to get the... I won't be worried about it. Taking your job, that's the smallest thing. There'll be a one world government coming very soon, probably, but we'll just go wait and see. But until then, we occupy until Jesus comes. Right, how do we get rid of the border? Yeah, it's just like brick dims, half. It was half brick dims. Multiplied by... No. Counts. Multiplied by the brick dims. What you saying? Okay, so that's supposedly loaded. So, the issue is the... We're not seeing it clamp, I don't think. So, number of bricks, half hit, so 2.5. 2.5 times the number of bricks. So, we should go from the center of this block up to somewhere like here. And we're clamping it. We should be like hitting the middle of the corner, the middle of these corner bricks, basically, and stopping that wall from appearing. But... Oh, hang on a minute. So yeah, I see the problem. So the issue is that actually in the center of the brick is actually an overlap for all these things. So technically it's wrong. What you actually want is the corner. So what you actually want is probably a rounded up version of that. Ugh. Oh, yeah, so or we could it's just multiply those, so it can happen in any order really. But then like oh, this is getting better. No, not really. Right. Oh. Yeah, so I don't know if a clamp is a sensible idea, really. Um, yeah, we don't really want a clamp. What do we want to do? We want to say if we go outside this boundary, then return. Oh, okay. I think that's what we want to do. We want to say Boolean. So this sort of logic, I think it is. This one. Oh. Is edge, if you will. I don't know what is boundary. Is let's just call it edge because it's shorter. So something like minus that, positive that. So that means instead of one of these GUV things, instead it's just like, sorry, CGUVs. Yeah, so we just say, right, if it's an edge, we just return D0, else we do all this. Okay. Oh man. Oh man. So that would be any. Oh, we didn't do the time 0.5. Oh, we're getting something. Right. Yes, I think the thing which is interesting is no. Uh so we're seeing like a fuzzy sort of edge here. Like, so you're seeing it's being fuzzy here, right? But here it's solid, right? But what we were trying to do is get rid of this whole thing, right? We don't want it. Actually, to be honest, oh yeah, it would have been fine. We want to get rid of like this whole area here, basically, and up here, and this up to here, basically. We probably round it as well, which would be nice. But, so we're trying to clamp it by clamping the. If any less than that. So we can do that is mouse at thing. Print out some of the stuff. Don't really need that anymore. Oh, those are kind of nice, but not needed. I'll comment those out. Probably comment those out as well. Right. So we can come into here and we can print out the, what is this? Right, is it kind of between -1 and 1? If so, right, it's just 1. Yeah, so what we're looking at doing is minusing off the border. What about minusing off like an extra half brick? What are we trying to... Right, so... Now the problem might be is that... Yeah, because it's a hard clamp now, like it's like an if statement, right? So the issue is that the ray is going to start inside the wall, and it's going to be a... What's going on here? That's not very nice. Yeah. Yeah, so you get this sort of effect here because it's starting the ray inside the wall. It's ray marched and then it's end up inside a wall, because you've now been allowed to start seeing it. So we've got this sort of conditional where the border only shows up when you sort of get close enough. Which is a big, big problem. So how do we solve that? Yeah, so we're sort of able to get it working using this technique. But it's as if like so what you kind of want to do is have these things working, but then your distance So less than automatically makes it a, you know, an edge. So what you probably want to do is some kind of like smooth step, if you will. And the smooth step will be like maybe have a smooth transition such that it maybe starts showing up at some point. At the equally though, you could just clamp the edge of the plane somehow. The problem is the plane is infinitely long. If you could have like a bounded plane. So dot, how much does that project across? That normal basically. How much does that project across that? Okay. So yeah, we don't want to clamp it, but it's you want to have like a bounded plane maybe. Is there a way to do that? Then more planes. Well, bounded plane would just be a box, right? Yeah. Bro, I know why I've been asking a lot of questions, my bad. No, it's fine. But do you have advice for me to get out of tutorial hell as fast as possible? Start making cool stuff that you wanted to make. Yeah, well, the best way is to ask people who like have already done it, I think. And the problem is software is complex, right? I do have a Discord, by the way. You on there? Like anytime you have a specific problem, ask, and I can help you through it. I don't know. Yeah, there's probably some other people on there as well who've done Vulkan as well. But you wanna um you do also have AI these days, which obviously can tell you wrong things, but you can use it to like massage the information which is on the internet into something that you can understand a bit better, right? So you, you can ask it to give you examples probably. Are they going to be like mostly right? I don't know though. I don't really use it. I use it sometimes to do research these days, and it's quite good at like, hey, what sort of techniques are available, right? And it can give you some different techniques. Doesn't get everything right, but it's better. It's just the way it can sort of like massage information down is something short and sweet. Um, but yeah. Um, what's the other thing? Yeah. Yeah, I think. Hmm. Yeah, I'll have to think about that one some more, to be honest. The ones in my brain have got any more advice. So we could layer up. So we could just do boxes repeated that are clamped. And then, yeah, I think that's probably best. We want to have like a plain. Right, I think this is good. So in box instead. This ABS stuff. Now the dimensions, you want you want it to be. You want it to be sort of this plain dims. So if it's across the X axis, say, there'll be plain dims.x. Right, let's just spell that out for a minute. Now what do we do? So that's going to be a whole. You know what? We could just do one box. All we're looking for is one box. Actually, that's all we're looking for, I think. We're gonna call it plain dims. Oh, it's half dims, isn't it? Oh, come on. Right, that sort of shows something. Huh? Oh, it's a repeated UV. That's why. Cool. There you go. That's it. Good. Right, so this is exactly what we want. So all we've gone and done is simply just draw a box to cover that inside area. So the issue is doing it this way is you have to have yeah, but because we've defined it with a number of bricks via brick counts, it means you can't end up like what's one? You can't end up inside the border, I think, for one of the edges. If we it always scales to the size of the box type of thing. I think that's right. Cool. So that's good. The thing I want to try out is an odd number of, sorry, an even number of bricks and then we can move on to something else. Okay. So if we pass in that, right, so as you can tell, an even numbers will have some problems as well. But obviously odd numbers, they work great. They're fine. So an even number, basically you don't have a middle brick. You're, what's the way of saying it? Well, okay, you do have a middle brick in this case. That's part of the problem. So I think there's be some kind of offset applied because you've decided to not have. Yeah, so this needs to be off. There needs to be an offset, something like a UV minus equal brick dims Z brick dims 0.5. Yeah, that's it. So that's fine, but now the border's busted. The border, hang on. So you want to do that. Like if it's so if it's even or odd type thing, isn't it? What's the way of saying it? So if brick counts and 1 cast to float, yeah, vec cast to vec3 times 0.5. It's gonna be funky. So like take your brick counts, you and it with 1, cast it to a floating point, vector. Why is it complaining? So not and 1. Right, you got to use the not function, unfortunately. GLSL. How do you GLSL bvec3 not? That's what we did though. Oh no, it's not a bvec3, is it? That would be so equals 0. There we go. Voila. So that does the so what we want to make this is the odd We'll call it even number brick offset. Right, it's just for even numbers only. So we switched back to odd bricks. It works fine too, yeah? Cool. And even bricks. Amazing. Nice. Loving that. So the next thing to do is we want to support probably some kind of brick offset. We had this in the code before. So we would kind of like that. We also haven't tested actually let's do non-uniform brick counts. So we want to have like a 2, 3, and a 4. Yeah, so we're seeing 2 across that way, 3 up, and then yeah, 4. So that's looking alright actually, I think. Let's swizzle it around a bit. Yep, looks fine. Lovely. Ooh. Cool. Yes, everything was brick offsets. So we want to have a way, you know, see when you see on a house, typically you have, you know, like a red brick, right? That sort of thing. They're sort of offset, right? Now, problem with offsets is that this border actually creates some problems now the way we decided to do the border. But maybe not. Maybe we can make it work. So if we change, so we're doing this thing where it's like if it's along the Y sort of, you can do an offset, odd even kind of, and I think you only really want to do it on the X anyway. Yeah, so let's not do Z, let's just do X only. So that could then mean the UV can get offset, providing... Okay, we'll get rid of the Z. So I think we can say... Basically work out what brick you're part of. Then offset your UV, maybe. Bit of a problem, really, isn't it? I reckon this will create glitches. Are we along the... We are along the Z or something like that, aren't we? So... Hardcode reload sometimes doesn't work on CPU. No biggie. Alright, so we're looking at it from the X side now. See, we are seeing a sort of an offset, but it's cut the brick in half. Right, so how could we get the thing to work with... See, it was changing the UV. That's probably the wrong way to do it. Maybe not. Hmm. Oh, there's an offset here, so... Yeah, it's conditional based on like where the sample point is. So as you're stepping, you could go down to like the next level on the bricks, and it's just like jumped somewhere completely different. So it isn't really a continuous like signed distance field anymore. It's sort of steps, you know. So that causes big problems. So what we should probably have is like instead, you should make 2 rows or or 3. Then you might not even have 3 bricks going across the dimension, but yeah, so I think what you should do is probably make three distances or 2 distances. And then repeat those basically. You make 2 rows and just repeat those. So in that way they'll always be around. So what you would like is this will be known as your brick. So then we need another distance for the sort of next layer above, if you will. Now, that... So... You'll still need the even brick offset thing. Let's just do this because I just can't be bothered to make the code look better. Let's try this for a minute. So what we want to achieve is you want like another one of these guys where you would like to insert this sort of brick offset basically to the UV. But it's got to be the next layer up. So that would be plus vec3 0. Now whatever z brick dims.y is, and then 0 on the z. Oh, excuse me. All right. Excuse me. So yeah, it's making something like it's better. Right, we've got stuff which is sort of like off the edge now and stuff like that. But right, so if we get rid of this, yeah. So as we I think it matters which way you go, to be honest, with that one. But if we times it by 0.1, we can sort of see it what happens as it goes, right? Right, so we're seeing it's going evenly across all the dimensions. That's not what we wanted. So what we wanted is vec 3, 0. Yeah, but you only want this on the layer up. Right, so they're all doing, okay, so the layer up's being repeated every time. Okay, so what I think you can do is draw 2 boxes and then repeat it. No, you got to repeat it before. Yes, the spacing, the spacing should actually be 2 layers. Well, it should be 2 layers of y. So plus the 0 z brickdims t ts dot y 0. Oh, I messed that one up. Yup. Right. So the spacing is like, we're seeing it kind of. No. Yeah. So we could ABS the UV as well, I think. Might help. No, maybe not. So what we've done is just made essentially the grid spacing larger along the Y. That should you're defining 2 bricks if you will, I think. But maybe what we could do is make it twice as much. And you define on the top and the bottom. Mm, yeah, so what I don't get is the offset thing, right? So, oh, okay, so we just have one. It's not going to repeat because, yeah. So we did a second one. Oh, come on, you don't reload? What's going on? What am I confused there? Oh, you get rid of that, that's why. Cool. Right, let's put that back. Yeah, so sort of what you want. Now, the offset, though, is sort of making it look bigger than it
I'd just like to
is
interject
for
for a
some
moment.
reason.
What you're referring to as
Uh,
Balenciaga is in fact GNU
Thank you
slash
so much for
Balenciaga,
the sub there,
or as I've
sir.
recently taken to calling it, GNU plus
Arminius,
Balenciaga.
Arminius, welcome, sir. Thank you for the resub. Appreciate it. Yeah, so we took that away though. Oh, and now it's right. These ones are not offset. I was hoping it would put in one. I'm confused. What's going on? So it's adding in. Yeah, so it is offset. But then because we put in this, yes, the way it repeats. So it needs to probably be 3. And then go to the layer above. That's all that's saying. Right, I have ideas what's going on. Right, so it's repeating every. Right, I see what's going on. Maybe. Hmm. Oh, it's a different grid. That's why. Alright, I'm doing 2 grids. No wonder why it's not working. So, what you actually want to be doing is you 1 grid. That's fine. But you want to be offsetting the grid UV, maybe. Right, okay. That's probably the issue. No. Is it pluses maybe you're looking for? Additions? No. That should be repeated. Um. Yeah, we're sort of getting what we want with that. It's just whether or not. Right, can we try and just hard code some values in here? Right, so let's take 0.1. Right, so we're seeing something clearly move. Cool. So what happens if we just did that along the Y? We sort of see it, yeah? Cool. Right, it's one of those things where could you ABS that and things just work out? No. I think we might have to do an extra box, basically. One box above, so that'd be brick dims.y. One brick below. Is it brick? Oh, it's got this TS thing, which we've got to rename anyway. Right, okay. Now it's got to add the offset. Uh, Z. And then it messes up. No. Why? Right, this offset is 0 to 1, isn't it? That's why. So brick offset needs to be divided by, hey, how big is your brick? Something like that, I think. Hmm. Right, times 0.1. Right, so... Oh, I did... Yeah, it's a ratio. We should call it that ratio. Cool, okay. So we're getting somewhere. So... Yeah, so we've got the same problem then if we do the offset the other way around. So it's a bit... So I think we can do it off with 1. It's just got to figure out to solve that issue with the brick disappearing, basically, wouldn't it? Right, so I think we tried to solve that with an absolute. But yeah. Um, yeah, see, so I think what you want to do is actually do this again, but then provide a different offset. Oh, finally. Right. Very good. So now we've got this other problem. So we've got some offsets in now. The issue is you got these bricks on the end, which we don't want anymore. So what we have to be careful of is like, yeah, this code really needs a good clean. We'll get to that. Let's just make sure everything works first. So we're actually getting into a good place where positionally, if you will. Hang on a minute, why aren't these ones moving? Oh, it's because they're on the row which they don't move. Yeah. Uh, hang on a minute. But you should do every other Z as well, right? Because, maybe. Yeah, because what you could do as well is do it down the Z. But then you also need. Oh, that would be a. There you go. Yeah, so things are coming into place now, positionally quite well. It's just. Yes, after we've got everything positioned properly, then we can say this distance, when it's basically done, it can just be cleaned up. And then we can move on to like doing noises and stuff on top of that and coloring it. It's getting good. We probably want to add some rounding as well to the border. So we've got a few problems, right? We've got this sort of like, we've clearly got some bricks which are, yeah, I wonder if we can do like a 3, 4, and a 5. Yes, you want all those bricks which are sort of hanging off. You want them to sort of be shortened, but then again, they're repeated. So we solved that problem by just defining a box previously. We couldn't figure out how to shorten it. You know, they're done with like repeating the UV, basically rounding it and scaling it. Right, so these fit perfectly on here. Right, okay, so they're not hanging off oddly. No, they're fine. They fit perfectly in the middle. Yeah. But yeah, maybe you don't always want this border box in the middle. But anyway, you don't want these extra bricks here, right? So when it comes to the repeat, on the ones with an offset, these guys, you don't want. You want to it's as if you want to take off uh 2 bricks actually, right? Is that right? Well, no, take off one. You take off 1 brick each, half a brick each side. So these ones are the offset ones along the Z and the Y. We can focus on the Y one. Oh, either way, let's focus on one of them. So, this code. So we want to somehow get rid of this grid thing is just going to infinitely repeat, right? Um, there is different operations actually. There is oh, you know what you could do? Um, you could have these planes which cut the edges off and get everything out. So that would be, there is operations for that. That's something we could do, right? So you could just have some cutting planes or cutting boxes, right? You just declare some boxes which go on the edges and just cut off everything you don't want. And that would include border. And then you could probably add a global rounding to it. Yeah, I think that could do it. So, yeah, one more look at. Yeah, so there's all these different units. So there's these three, right? So you've got union, subtraction, intersection, or XOR. So obviously we've got subtraction, right? So you could subtract these cut planes. So you put everything down. You even put like if a subtraction puts a hole in it. Yeah, so you could put these planes down at the edge and subtract it off and just cut everything. And you'll make nice smaller bricks at the edges as well, perhaps. Um, and then you can round them afterwards, but then the brick dimensions won't be even on the edges as well. I think this border as well is going a bit deep. It might be nice to... Yeah. We probably want to have a configurable parameter to change something like this border, which is this one here. You know, make that a little bit puffier, right? Sort of choose the depth of that. And this depth could probably... It kind of impacts how much you want to... Yeah, that's the thing. So we could do this border a bit differently, where there's some cutting action going on, if you will, maybe. I don't know how we'll do it. And that could also then cut off the edge bricks, which are sort of hanging on the edge. Or they're hanging off, right? And then it could also cut off... you don't really want it to cut these ones off, but you can skip them because they are separate. You know, these ones are the offset ones, right? So yeah, I reckon you could. So subtraction is just going to create a hole. No, it is going to subtract from it. Yeah. Yeah. So we'll get op subtraction in. Let's just get these in. So we could probably have a union. You could probably overload that, right? Yeah, so I'd like to overload that. Cool. So subtraction. Cool. Intersection. There's an XOR one. I've never used the XOR, but that would be where they both are. It's a not equals basically, isn't it? Yeah, so yes, it's a not equals. So like it will be where they're both where they are, but the other one isn't, I think is the way of saying it. I don't know, that just feels like a union to me in a way. But anyway, we'll do it. We'll just put it in there. Cool. So yeah, we've got the subtract now, which is really nice. So I'm thinking to simplify the distance function a bit more, we can actually, the box can just cover the whole space. Then you define a clipping, um, yeah, so we wanted to find like a clipping box, maybe, which goes at the edges of the area. So the clipping box would be, the dim sort of gets you most of the way there. So C box min, and then C box max. So max will be first, and then yeah, take that. Then so this would be, you just draw a full-on thing which covers the whole area. That'd be like a vec. One. Yeah. Then we just do an SDF. So D1 equals SDF subtraction of D1. Oh yeah, then you want to do another one where it's like so you want to have there's a border box, isn't there? Yeah, box frame. That's what we want. Box frame. So if we get a box frame, then that simplifies our code even more. Oh, this is going to be great. So B will be half dims. E is, I guess, the thickness of the border, right? All right, here we go. Oh, this is gonna be good. So here's the plan. Here's the plan. We draw ourselves a box. So be UV. Should I worry about any of that? Then right. Yes. So the center of the yes, it's the offset from the center of the thing that we're drawing. Then half dims. The half dims would just be 1. So this should hopefully just simplify a lot of this code since it's compile time constant there. Then the thickness would be, you want some value passed in. It's like how much of a well, yeah, I think we want to have another parameter called like uh, border deepness or whatever, the deepness value, and that will go from how deep does this go? So obviously it's normalized, and that'll get you. It would be probably the size of border thickness. Is that right? Border dims. Oh, is this not? It's not a vector, is it? Mm. Right, that's going to be a bit of a problem. Wonder if there's a different version. Yeah, so that will be render. Pretty cool. So it seems like it's doing it across to Q. So I wonder, right, if you can do something funky, right? Let's try it out. So if we make Q 0, 1, 2, right? Just multiply E by 0.5 here, and then do 0.25 the other side. Now, your first line would be Q0, next line would be Q1, then Q2, Q's and P's, wow. Right, I think that might do it. Yeah. Looks like it's done it. So, excuse me. That's what we want. That's the modified version that we want. So we can support different E's basically. So 3D thickness. All right. Two, 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 yeah? Oh, lovely. So, that works with our thing now. So, times by this sort of deepness. So, how deep do you want it to go? That's fine. Right, lovely. So, we'll pass in that deepness. So, border deepness. Oh. So, great. So with this, it gets you back some kind of like, hey, what's my distance from this subtraction thing? So subtract your D2 away from there. And boy, whoopsie. So it's showing it up now, which is interesting. Not really a subtraction, that's kind of a intersection, if you didn't. Hang on a minute. Um, yeah. Let me just go back to that sort of SDF 3D functions. Because I think, let's just double check with the subtract, right? Yeah, max negative A, positive B, right? So max of negative A, positive B. So D1 would be the box, right? So if you're inside the box, it'll negate it. It'll negate it and make it positive, right? So this box just covers the whole area, right? So so if you're inside the box, it makes it negative. Sorry, it's negative, so it will negate it. So it'd be positive, meaning it's outside the box. Now it's saying take the maximum between that and D2. Well, yeah, right. So maybe we're looking for um, could it be XOR that we're looking for? This feels no, it's not that then. It's not intersection either. Yeah. So maybe it's something else. Can't be a union because that's just going to keep adding to it. So like, what I want to do is use that as the sort of cutting, like cut out the SDF of this box here. Strange. Super strange. Yeah, so this box basically, I wanted to cut the corners off with the frame, but I'm not getting that. Like if I get rid of, if I just display D2, like it's that frame, right? So what we wanted to do is, oh, so it seems like we've done it the wrong way around, right? We've cut. Oh, really? I don't know. If we just play D2, it's that. Right, so that needs to come away from box. Yeah, so something's wrong. Something's fishy. Because like, right, you've got this intersection, right? Where is it? This is subtraction, right? It's got a box. You've subtracted a sphere away from it, right? So the sphere is in there. Now the sphere is obviously right. So you have when both distances are overlapping, it will be the one which is outside will stay. Sorry. Yeah. So if they're both overlapping, then obviously it's as if it's not anything there. And it just keeps ray marching. Now, obviously your distance for A is the box and B is being subtracted away from it, I think. So that will be, yeah, so, yeah. So, or is that true? No, I think it is the other way around. Yeah, so basically you get, the one which gets negated is probably the sphere. Because otherwise, oh no, you're finding the max, aren't you? The maximum number. So, yeah, it is the right way around. What sort of operation do we want to get then? Hmm. Right, I'm gonna take a quick like few minute break. Just gonna get a drink and things like this. And then we'll try and solve this problem where we're trying to basically cut this border out of the out of another box. And that can be our that could be the cement layer basically, but also cut the excess bricks off. Basically just cut them off with this one big cutting volume. That's the plan at least. Right, I'll be back in a few. Right, welcome back, everyone. Okay, so what we're working on is we've got some bricks. We also have a volume which displays the cement layer essentially, and we're trying to also cut off these excess bricks as well, right? So I'm trying to do this subtraction thing. I wonder if you can subtract D2. We're trying to subtract this sort of like this. So that right there subtracted the bricks away from the volume, the other one volume. Yeah, that's sort of what we want there. Kind of. There's a few issues with it, to say the least. So that's part of the problem. I will call this the wrong way round because subtraction to me is on the right hand side. Right, the thing you're subtracting goes on the right. The thing that's taken away from the other thing goes on the right hand side, right? But there's that. Unless something else is wrong, but that seems to be what the problem is. So the box that we're making, which is this thing, hang on a minute. Let's make that 0.9. No, 9, see what happens. So we move it down. So what we're seeing then is that's hollowing these things out. So what we're seeing is this border dims is kind of not big enough. Hang on. Oh, maybe we should do... Right. Cool. So the issue is, so we've done, these are so it's a 5x5 brick, but we've also offsetted some of them. Right, we want to use this cutting volume to cut the ones which hang off the edge too much. But the ones which are fine, they shouldn't be cut. So those ones are part of the these ones here. So what we want to be able to do is get this distance to the cutting volume. So the cut distance. Again, we can clean this up as we go. Sorry, we can clean up when we've got it working. We'll make this look super nice. But let's just get it working for now. So these ones do the offset bricks. So that will then just be a D0. Work with me. There's no D2 anymore, it's a CD. Oh, crap. There we go. Brackets in the wrong place. That's what we want. Kind of. Yeah. That's good. So we're still getting these sort of dangling bricks here, but I think we can round the whole thing, which would be sort of nice. So edge dim. So we probably want to have like a roundiness, maybe. Something like that. So a bit like border ratio. Should have another one called. Right, so rather than put it in here, right, instead, overall, we're just going to subtract it away. Which just means it makes it smaller. So it means the ones on the edge should get rounded. The issue is, though, everything will need to be made bigger by this brick half dim. Cool. So is that really looking good? Let me undo it quick. It's got puffier. Oh, so we should have taken it away, not added it. We just got to remember all these little things we're doing. So when we clean up. Right, so my issue. Right, let's just try that out. So it's looking all right, I think. So if we move the camera around now, so game.c, let's put the camera movement code in. Right, this is going to be good. Okay, let's see what's going on. So they're offset, nice. I was hoping to get a little bit more roundiness on these ones here where they're cut. These cut ones here. Yeah. So they're not cut enough, that's the issue. Need more cut. So let's get them cutting. So see our clipping volume. We can just see it by returning CD. This is our clipping volume. So it's based on this sort of like, I think it's too wide. Right, so maybe this needs to be ×2. No, it's too much in it. So I'm trying to see, can we get them more rounded, these types of bricks here, right? Those sharp edges, I don't really like them. Not really working. Yeah. All right. So I'm wondering with these sort of like, Yes, they are cut halfway down, right? But then, yeah, it's the weird thing about it, actually. It should be cut more one side, actually. Are we looking more of a brick dims? Ah, the Y and the Z are wrong way round. In the frame code, I think. Yeah. So that would be CD. So I think what's going on. Maybe not. I think this is it. Those Q1s got to become Q2s. Now these. You got to swap the Y's and Z's around, didn't you? That's not too bad. You know what? Let's undo that. We can manually tell. So that will be oh, 0.1, 0.2. Crying out loud to do that. Yeah, these are definitely the wrong way around. Well, wait a minute. So we see, so they're colored based on the normal, right? So red is X. So the X axis is very thick. Yes, I think the way we can fix it. So the thickest needed to be where Z is. And then the second largest was Y. And Y is very tall. No, Y was very thin. So that would be. Hang on a minute. I'm sick. I'm confused by these ones. Can we make them like? Right, let's try a different order of magnitude, I guess. Oh. 2, 4, 8, maybe. Okay, so the 8 thickness one, that's the x-axis, right? That's clearly wrong. So it's the z. Next, what's the thinnest feature? Actually, maybe splitting this out of this is not is not correct, is it? Or it's kind of square in it. Yeah, these are kind of square. So actually, this is not right. Hmm. Right, so you probably need to do some. Okay. I wonder if it's a case of basically swizzling these around, but could be wrong. Not quite. So the thing that makes it look wrong to me is they look square. Wait, or should they be? So we've got a border. Yeah, border along the x-axis, border along the z, border along the y. Um, actually, maybe this is fine. Yeah, maybe it is fine. All right, let's reorder them. So it was Z and X needed swapping, that's for sure. Okay, so the Z is the biggest, so that'll be the ones with the blues. Yes, you see it's the thickest, yeah? Then the Y is the... Yeah, what would be the Y in this context? Because it's up and down, but then like... Yeah, maybe it is a bit wrong. Yeah, because it's square, isn't it? You're not really sort of rectangular. Hmm. What was that return? Right. Because each axis. So maybe that was the thing to do. Q0. Okay, that's better, I think. Yeah, so now they're kind of 3D rectangular, what do you call that? A cuboid, I think you call it. Yeah, they're a cuboid rather than equal on two edges out of the three, 2 dimensions rather than the three, yeah. Right. That's what we want. So it's even easier to modify. Alright. So yeah. So can we test it out quick? If we add just a bit of Z, what happens? Sorry, a bit of X. Yeah, it just makes the X bigger. We saw that, right? Shorter, bigger. Lovely. So my thing is that I don't think... Alright, it's not times by 2. Is it brick the size of a brick? Then half. Not quite either. So plus border, I think it is. Yes, plus border. No. It's Z brick dim take border. Oh, bizarre. Hey there, John Deadeye. How you doing, sir? Welcome. That's all right, no worries. Yeah, I've just been messing around with bricks and stuff, materials, but mainly on this brick shader. So we tried parallax occlusion mapping first. We just tried to do it. It's just a 3D texture. We tried to do it in kind of like then parallax occlusion map into a slice of it as 2D, but didn't work out well. So now we're just ray marching it basically. We've tried out a bunch of different things. We've tried out like adding noise to it and stuff like this. So now I've just gone back to the drawing board of like how do I define the shapes and stuff. But yeah, things going all right. Once we've got the first material done, then the rest will be a lot easier because we'll have an example to pull from. Plus, yeah, all the functions will be there as well to use. But yeah, we're just trying to make a really nice brick shader. Also, as well, trying to fit in some performance budget as well. But it's coming along all right. We're just trying to lay out, trying to get the brick offsets and everything correct, and also cut off the certain these edge bricks. And then place that we have a border which we're trying to place down as well. It's somewhere in this code, in this soup of code here, which will get cleaned up when everything looks good. But yeah, it's a bit of a fiddle. How's things going with you? What stuff have you been up to? Part of me thinks, yeah, I probably need to stop the camera. Camera spinning is like not really helping now. It was cool. You know, it was great to see some of those bricks we couldn't see, but what I'd like to do is get a fixed angle, you see. Alright, so here's the cut volume. Boom. Right, so it's this sort of thick. Why? Because, so it could be even thicker. That seems too thick. Yeah, that's the distance of 2 bricks. So that's a half. Right, that's why. There needs to be some sort of half action going on. Kind of thing. Right now it's not enough, probably because this border dim's not really... Yeah. You see, I wonder whether or not... Mm. Right, where's the rotate 90 degrees? Go the other way around. Oh. I was going to crash in it. Nice, amazing, good to hear. Yeah, I think it's coming along. Bit slow for the materials, but it'll be cool. It's just if you think about it, this thing defines like quite a lot of how the game looks. It is very important to get right. Plus, we're doing something in 3 dimensions, which people typically do in 2. So it's a bit untraditional. Plus, it's all done procedurally as well, which is another untraditional thing about it. But yeah, it'd be very nice. So we're gonna have layers and stuff. Like the bit that I really want to try next is right. You get these bricks, and then you have like a moss layer that comes on top. That in like the crevices here, you can get like some nice moss, and we'll just use some noise, right? To do that, it'd be cool. Um, hmm. So why? Like, what? Basically, I'm expecting this, like, to be aligned exactly with the center of the. Oh, you know what it could be? It's because these are like offset and regridified in it. So the cut ends up at a different place. Yeah, yeah. So if I were to cut D0, hang on. Oh, it's just look. So this is the ones which are not offset. So these are offset on the X, you can tell, right? But these ones are not. These will get cut as well. And they cut different offsets because, see now. Yeah. They cut different offsets because, oh, you bugger. They're kind of in different spaces. So I've regridified it with a slightly different offset. Is that true though? Does it just collapse down to distance value? Yeah. I don't know if that's true or not. Right. Let's see. We'll see it from a different camera angle. Yes. So, uh, if you see here, no, I think it's pretty fair. Yeah. So we can end up increasing the cut. Yeah, and it's pretty much the same. Okay, that's good because I don't want to solve that problem. That problem would be horrible. So in that case then, Right, I think we've got to move the camera down. Yes, we're not getting rid of the bottom. Right, let's get rid of that cut thing. So I'm gonna cut the aligned bricks. So this thing here is like essentially a lower right of, but it is being cut on top. Right, so that means the Y is, hang on a minute, and we've got even number of bricks. 5 by 5 by 5. Oh, it's offset by 0.5, isn't it, along the X, right? So right, that'll be halfway through that brick. Um, hmm. So the Y border dims. Not really the border dims though, is it? Yes, the more and more of this that we do ends up cutting that right off. Cutting the other one off as well. Okay, so only the X has been offset. So we don't offset the X. What happens? Right, that's another interesting thing. Isn't this supposed to be even? Like it's a 5 by 5 by 5. But then we've added. So that means it should be cutting the top portion off this brick as well. Here. But as we move it further to the right, it bumps into the yeah, it bumps into the border right, so are my border dims like not uniform? That's the word I'm looking for. Have a look, shall we? Oh, excuse me. Or brick edge dim. Yeah, they're the same size, so they're the same. Yeah, so we find out the uniform. So that's the bizarre thing about it. So it's actually physically square as well. You know, it's cube. Um, so if we change these offsets, times them by 0. Not that. What was it called? Wait, it's a subtract here, isn't it? Sure. Well, um, right. Why is that cut? Why does it not come from the top as well? Right. Okay. So we've offset. We tried to offset these, and we added it up by 1. Interesting. Right. We have moved it up by 1. Right. This is contributing it to it probably. So because we've done that. Right. I see now. So because we're changing the levels, it's actually not bumping into the border properly. Yeah. So, what a bugger. So to get the offset looking nice, I've basically had to repeat. What's a good way of saying it? Or showing it, should we say? Because it's better to show rather than tell. So I think I can just change these to UV maybe. Yeah, so basically we just build one brick which is directly above it, and one which is there's actually 3 bricks there. One which is down and is offset, one which is ahead and to the right, again offset on the Z, on the X, sorry. And then we just repeat it. So because we're offsetting them on the Y's and the Z's, they end when we do this subtract. Not sure that's true. Yeah, because it's just working with a distance from the edge. Maybe. I think I just need to move over just a tad, you know? So should that recompose? I'm crashing it. It's fine. Right, we've got the sort of more aligned camera angle now. So we'll swap out for the bounding volley. Yeah, then if we offset, now change the C and just show the cut and volume. Hmm. Can I move that just a bit? I'm interested. All right, so D0. Yeah, it seems like. Hmm. Yeah, you can see the thickness of that, right? You would expect this top to be cut, I think. But anyways, things to sort out next time. Right, I got a jam now, guys, but reasonably good session, I guess. We've been made some progress. Just got to figure out this how to nicely cut everything up so we can put a box down and cut it and just use that for the cement. And then also just cut out the offsetted bricks as well. That's the other thing. But anyways, there is a Discord channel. We're going to come and chat in the meantime. And yeah, if you feel like you want to support the channel as well, we do have a way to get access to the code and run on your local machine. And thank you for everyone who's supporting the channel as well. Appreciate you all. Have a good start to your weekend. I'll see you all on Sunday, hopefully. There's the timetable down below. Also, if you join the Discord channel, I post sort of like what we're doing next and things like that, and future plans in there, and among other things. Radio, have a good one. Catch you later.